Everybody, this is Mr. Hodges, and this is Perfect Practice video covering equilibrium and the calculations of molarity for concentration. Work should go on to Interactive Notebook page 45. I apologize for the previous video. Apparently we had some issues with sound. So let's just get right into it. Remember, pause the video, work the problem on your own, and then press play to see the answer. I will pause for just a few seconds in between each question to give you an opportunity to hit that pause button. But in case I go fairly quickly, just keep that in mind. All right, so problem number 1 says calculate the number of moles of sodium hydroxide present in 35.0 grams of sodium hydroxide. The molar mass is 39.998 grams per mole. So this is a simple one-step conversion problem. You want to set up using our standard dimensional analysis chart here. This gives you the fraction. So starting here, we're looking at the fact that we have grams. So because we have grams, we want grams of sodium hydroxide on the bottom. We are converting to moles of sodium hydroxide, so that goes on top. And then looking at the molar mass, remember that this means that there are 39.998 grams in 1 mole. Okay. So because of that, at the bottom here, we're going to put the 39.998. At the top, we're going to put the 1 mole. And then going over to our calculator, clear this out, we're going to put in the 35.0 divided by 39.998. And we're given this long decimal. Looking at the number, I have 3 significant figures, so I want 3 significant figures in my answer. So 0.875 is going to be the final answer. So 0.875, and then the units, moles, wow, NaOH. Okay, so, and that's a 7. Okay, problem number 2. Calculate the molarity of a solution made with 35 grams of sodium hydroxide dissolved in a total of 0.545 liters. So for this problem, the given information, we are told what the mass is. So the mass is equal to 35.0 grams of sodium hydroxide. And we're told that the volume is equal to 0.545 liters of solution. The problem is, for our unknown, we are looking for molarity. In order to do a molarity calculation, we need to know moles. Well, it just so happens that in the previous question, we saw 35 grams converted into moles, so that we know that this is actually equal to 0.875 moles of NaOH. Okay? So from this, we can then go in and calculate our molarity. So molarity is equal to the number of moles over our volume. Number of moles in this case is 0.875 moles NaOH. Just extend that line all the way across. And then 0.545 liters. So we're going to end up doing a division. So once again, going to the calculator, 0.875 divided by 0.545. Oops. And we get 1.605, so we're going to round that up to 1.61. Okay, so 1.61, and then the units, we have moles on top, we have liters on the bottom, so the units are going to be moles per liter. Oops, let's fix that. Oops, too big. Erase it all. How about that? So we're looking at 1.61 moles per liter. Okay, the negative one there means the per, so the liters are going to go on bottom, and then we need our identity, so sodium hydroxide. All right, question 3. If there are 3.90 moles of sodium sodium chloride dissolved in 4 liters of solution, what is the molarity of the solution? So again, if we list out our givens, okay, we know that for the number of moles, we have 3.90 moles of sodium. Oops. Keep doing hydroxide. I got hydroxide on the brain. Sodium chloride, we know that the volume of the solution is 4.00 liters. Okay, and then our unknown is molarity. Wow, my pen is just not working very well today. All right, so molarity is equal to moles over volume. So 3.90 moles NaCl over 4.0 liters. So going back to a calculator, 3.9 divided by 4, we get 0.975, 3 sig figs, perfect for our answer. So we have 0.975 moles per liter NaCl. All right, question number 4. Write the equilibrium expression for the following reaction. So solving this should be really quick and really easy. The format for this, for the expression, we're looking at solving for what's called the equilibrium constant. Okay, so the equilibrium constant is a measurement, a mathematical relationship based off of concentration. Remember, that's what the C stands for. C equals concentration. Wow, my pen is really acting up today. All right, so, and it is products divided by the reactant. So we want to put the concentration of our products. So NaF is our first product. Okay, we're going to put that in brackets to indicate concentration, and then we're going to look out in front. No number out in front means it's the number 1, so this gets raised to the first power, which we don't need to record because anything raised to the first power is itself. The second product, we're going to put in brackets, and again, no number out in front of the H2O, so we're just going to put H2O in brackets. And then on the bottom, we have our reactants. So in brackets, the first reactant we have is HF. Okay, again, no number out in front, so we're going to raise that to the first power, which we don't print. And then the second substance is NaOH. And again, no number out in front, so no need to raise that to any power. So it's just the concentration of NaF times the concentration of water divided by the concentration of HF times the concentration of NaOH. Question number 5. Write the equilibrium expression for the following reaction. So again, we're looking at writing out for the equilibrium constant. Our reaction is a little bit different this time. So the equilibrium constant Kc is equal to concentration of our product, SO3. That should be a 3. And this time, though, there is the coefficient 2, so this needs to be squared. That's the only product, so now we go to the reactants. We have our first reactant is SO2. And again, this has a coefficient out in front, so we want to raise it to the second power. And then the second reactant is O2. No coefficient out in front, or I should say the coefficient number 1, so we do not need to raise that to the 1 power, so we're good to go. Question 6 says, using the equation for number 5, calculate Kc if the equilibrium constant for... calculate the Kc if... Wow, this question is worded poorly. I apologize for that. So here's the concentration. And so we are looking for the actual number value for Kc this time around. So looking back up here, we want to use this equation for Kc down here. So Kc is going to be equal to the concentration of SO3, come on, squared, divided by SO2 squared times O2. Okay, and we're just going to plug in these numbers. Okay, so starting with SO3 here, the concentration is 0.59, so 0.590, and that number is going to get squared, divided by the concentration of SO2, which is 1.12, 1.22, and that number is squared. Wow. Apologize for my pen. And then the concentration of O2, which is 0.945. Okay. Now, when you put this in your calculator, there's a couple different ways you can do it. Okay. You can solve for the top number, write it down, solve for the bottom number, write it down, and then plug those two numbers back in. Or you could do it all together starting with the top. So this is how I would do it. 0.590, and I want to square it, so squared. And then divide by the first number, which in parentheses 1.22, that number is going to get squared. And then I'm going to divide by the second number, so I'm going to hit division again. 0.945, hit equals 3 sig figs at each number, so 3 sig figs in my answer, so 0.247 is the final answer. Okay, 0.247. Okay, now units, don't worry about units right now. We're primarily focusing in on just getting the numbers in and solving for it. Okay, and then question number 7, last question, it says, using the equation for number 5, calculate the Kc if the equilibrium concentration of the substances are. That's the way number 6 should have been worded too. So again, we're using the same equilibrium expression. So we're still dealing with Kc is equal to concentration of SO3, there we go, squared, divided by SO2 squared times O2. Wow, got the 3 right, but not the other 2. So we just have new numbers here. So I have 0.407 squared divided by, oops, I did that wrong, I apologize. Let's fix that. SO3 is the 0.197. That needs to get squared. There we go. And then SO2 is 0.407. That is also squared. And then the last one, 0.315. Okay. So Kc equals, going back to our calculator, 0.197, and we want that squared, divided by, open parentheses, 0.407 squared, close parentheses, divided by 0.315 equals, so our final answer here is 0.743 is followed by the 7, so we're going to round that up to 0.744. So the final answer here is 0.744. All right, guys, that's all 7 questions. If you have any questions, please bring them into class.